Welcome to the Industrial Talk Podcast with Scott MacKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, once again, thank you very much for joining Industrial Talk. Thank you for your continued support of an ecosystem that is ever expanding and celebrating industry professionals all around the world. You are bold, you are brave, you dare greatly, you innovate, you collaborate, you solving problems each and every day. And we truly, here on Industrial Talk, appreciate that, and that's why we celebrate you. You are the heroes in this story. We are broadcasting on site, once again, OMG Q1 meeting, and it is a collection of problem solvers. You need to be involved. You need to consider getting involved. Go out to omg.org, omg.org, and you get to find people that are like, and I'm going to butcher his name, I'm going to Gerardo. See, he's got the tongue and everything. It's all good. It's all good. So let's get cracking. Good meeting. Seeing how you've been a part of the OMG family for 20 years, since the beginning. 20. Did you have hair back then?
Yeah, I did. I still have some.
Yeah, like I have. It's like after a while, it's not even worth trying to protect. Yeah. So you've been coming to these quarterly meetings. I'm very intrigued. I'm intrigued by DDS and especially how all of the conversations that are really happening today that are around digital, or around the data, around that whole data conversation. I need data. I want clean data. I want to be able to do it. I don't want to cause. It's just non-stop because we're trying to be more connected. But before we get into that conversation, give us a little background on who you are.
I work for a company called Realtime Innovations. We are a spin-off from Stanford Robotics Lab, and we got started trying to build robotic systems like 25 years ago. And then when we were done with our, different degrees, PhDs, and so forth, we kind of were looking for what to do, and we started a company trying to do the same things in the real world. And things kept going, but one of the things we did was build a software infrastructure to make the people's lives easier when they were trying to develop these kinds of systems.
So I have to pull on the thread a little bit. Real-Time Innovations. What is that?
It's the name of the company.
I know that, but what do you do?
What I do, I'm the Chief Technology Officer there, and we build software platform, software infrastructure technology. We build like a system based on DDS that is a software kind of platform that other users would acquire and use to build their systems upon. It's like an operating system for distributed systems. That's a way to think about it. A mouthful.
It is. Oh my goodness.
But you want it to be technical.
Yeah, I do. And I can handle it, sort of, maybe a little bit. So for the listener out there, DDS has been around for a number of years, and in fact, I think it's the 20th anniversary. Just explain to the listener what it is.
So, like I said, operating systems is a good analogy, right? People want to build applications, but they want to be dealing with the low-level stuff of like how to manage memory, how to manage access to files, disks, and so on. When you build a distributed system, you have a very similar needs. You're trying to build your application, you're trying to create data, process data, and so on, but you have to get the data from here to there. And how do you get the data from here to there? It's complex, right? So you want support in your software that makes the data move easy, that allows you to build an application that can communicate with other applications without worrying where those applications are. Are they running on the same machine? Are they on a different machine? Same operating system? Are they over a network? You don't care about that. You're just focusing on your own logic and what information you want to exchange.
Does the DDS solution, platform, whatever, also take in consideration applications, talking to other applications at communication level, and of course me, let's say I'm Scott MacKenzie, manufacturing, and I just need specific information, and I don't want to see how the sausage is made. I just want the data.
Right. It's another layer, right? Of course, there's a lot of layers of software, so that, somebody's going to build a layer that deals with how to put how to send data, but at the level of like 3G networks or Ethernet or something like that. And somebody then build another layer on top of that, saying, well, how is that going to be routed, like the internet, right? Then somebody else builds another layer that says, well, you don't really want to be sending bytes, you want to be sending data. So, and what kinds of requirements do you have, quality of service you have at the data level? How do you secure that, right? Each one of those layers kind of moves the abstraction higher to what you care about, which is like, I'm producing some position information about my vehicle. I want to know what's around. Is that a car? Is that another person? How far is it? Right? You're trying to access information from other systems, but to get information, you have to go through a lot of layers of software and hardware. So we're abstracting all that on top of other abstractions that the operating systems and the communication transports provide.
To help sort of somebody understand what you're talking about, because these are conversations that, from my perspective, require some sort of box and an arrow,
right.
and there's a visual representation. The only way that I know how you can try to truly visualize what you're talking about. Do you have a specific use case that can help the listener understand with what you're doing?
So, sort of the key to building a complex system is modularity, right? You want to build applications, build up components, and then kind of assemble. So a use case would be somebody's trying to build a vehicle. Autonomous vehicles are hot today.
Autonomous.
Right? Okay. So, how do you mean an autonomous vehicle? Well, you need to have sensors like cameras, and those cameras are producing images. You need to have lidars or radars that are producing sensor data. You have to have some kind of AI algorithm that recognizes those images and classifies them into people, this and that. Then you have to decide, well, what am I going to do? Am I going to go forward? Well, you have to send signals to an engine, right? All these pieces are separate components that have at the software level some kind of interface. You send some input, it produces some output. So in order to be able to define those boxes and to break the problem apart so you can have 100 engineers or 1,000 engineers each working on the different piece, you need interfaces and you need sort of an infrastructure that moves the data from one component to another. So that's kind of typical application. People trying to build modular systems, defining interfaces between their components, and having something that essentially says, well, if you meet your interface, you produce and consume data the way you said you did, and somebody else does the opposite, the complement to that, then the infrastructure will move the data from A to B and resolve all the complexity that is in between.
Is there a potential for latency?
Of course.
How do you address latency in all of this?
You address
because when you start talking about autonomous vehicles, right. You're talking about I can't afford latency.
Right. Building it on top of infrastructure that is trying to minimize latency. There is networking technology, like time-sensitive networks. There is operating systems like real-time operating systems, right, which take very careful care of how long things take, and therefore you can estimate and bound that latency and know that you will be able to make a decision at a given budget of time. And then you don't drive any faster than you can afford to drive, right. Just like a human wouldn't, right?
A lot of the conversations also, evolve or revolve around security.
Right.
Take us through that focus in security on in the DDS.
It's interesting because you said earlier, it's all about data today, and why is it about data? Is because data is very tied to the physical system, right? Like people or cars, they have a position, they have a speed. A human, in a hospital, has a heartbeat rate and so on. We can agree to that. This is timeless, right? Things don't change. It comes from the physics, from the biology, and so forth. How we use the data is very different, right? So there's all kinds of, let's use the data this way, let's have this kind of functionality. So in security, it's also the same kind of thinking. Like in the DDS approach, we focus on securing the data. So if you're producing data, each type of data flow has its own security and gets protected by our infrastructure. The alternative to that is sort of securing the communications channel. You are not protecting the data inside, but rather you are making sure that nobody sees what you are doing. So that's kind of the more classic, HTTP level security, where you are kind of encrypting a connection and then sending data on the clear on that connection. The problem with that is that everybody that is in that connection needs to be able to see the data inside, right? Whereas when you're securing the data, you can then send that data over any channel, and then it can go and flow through many hops until the destination that has the necessary credentials to actually see the data. So that's what we call data-centric security, and that's kind of the approach that we're taking in DDS. Securing the data so you can specify who has access to what, and then the data gets protected at the source and can only be seen by the ultimate recipients of the data that have the right credentials and the right keys.
I can see when it's, and forgive me for the term that I use greenfield, brownfield, I use old industry terms. Mm-hmm. If I'm an existing business, I find it probably easy to build something new and take in consideration what DDS provides, and then make sure that I architect my systems in a way that makes sense. And it's like I can have that conversation, but I'm already an existing customer. I have systems. I've been in business for years, and I want to deploy DDS. I want to be able to start doing that, because I know that I have, well, here's an interface here, here's an interface there, it hits this table, it hits that table, and it pulls. It's inefficient at best.
Right. You've got to normalize into something, right? It's kind of like English. Why is that most spoken second language in the world, right?
Yeah.
Because everybody says, well, I can speak this and speak that and speak the other thing, but in the end, we all have to agree to something so we can all communicate. So, yeah, you're going to have systems built on all kinds of technologies. If you want those systems to be integrated, you don't want to have to build bridges from every system to every other system, because that would be like an N-squared problem, right?
Yeah.
But you can say, well, we're all going to speak our own language and also speak one other language that we can normalize to. And then if we don't speak the same language, we're going to translate to this common language, right? So DDS is a very good way to do that thing, and that's how people build those systems. We see it in, for example, healthcare. Like, people are trying to integrate a hospital and get all these devices to talk to each other. They all have different protocols.
Yeah.
So what they do is say, okay, we're going to put an interface on top of that reads your own proprietary, whatever protocol it is, and it's going to normalize into this data-centric world. And since all we agree on what this data-centric representation is going to be, we can all communicate to each other. I'll translate from my own proprietary protocol into this that goes over Ethernet.
But as long as you have a common.
You have to have that common, and that's what DDS provides you, a language through which you can define this common protocol, your common quality of service, and then everybody can go into that. So you can either build an application that is natively already speaking that, or translate into that for the purposes of...
So in a scenario where I have an existing business and I'm getting ready to deploy a new application,
right.
I just have to make sure that how that application communicates to this common source, so that I'm able to pull everything out.
I mean, if you can think of how the internet has been successful, right? Something called REST and HTTP became this lingua franca. Like, there was hundreds of other kinds of different protocols for, file transfer, for this and the other thing, mail, and so on. In the end, they said, well, we can normalize everything into HTTP and REST and so on, which is the communication protocol that you talk to, your Amazon store, everything goes, your teleconferencing, everything goes to that. Now, that's been great, but it's not for machine-level, real-time type of speed. So kind of DDS provides the equivalent when you're trying to do like real-time performance, latency-sensitive type of applications.
Yeah, that makes sense. Where, you've been involved for 20 years, so you've seen a lot of changes happen. Where do you see it going now? What's sort of on the horizon that you see?
So we're seeing obviously an emphasis on security, right, and large-scale systems. Those are things I would say the more dominant focus, because security is everywhere now. Before, people thought, well, as long as I only operate inside a box, right, I need to worry about. But there are a couple of problems with that, like, because any vulnerability into a system, which could be through the weakest entry point, will kind of damage the whole system. Now that the system is really depending on software so much, like we've seen that with cars, for example. Somebody hacked into their tire pressure sensor and drove the car, off the road, right? So you can't think your system is going to be isolated, because something could be hacked. But beyond that, it's like everything is becoming software defined these days, because people want to take advantage of AI and all kinds of stuff. And then, you're trying to integrate systems, and then at that point, all bets are off. Every system is connected. So every system needs to be secure at the source, basically. And the second is this scalability, right? Because now that you're connecting your system, what used to be your isolated truck or your isolated device somewhere, medical thing, is now part of a much larger system.
Yeah.
And therefore, things are going to scale to hundreds of thousands of millions.
And you want it to scale. You want to be able to pull in, using the healthcare analogy.
Right.
I don't just want this one device just be standalone,
right.
and I can't see how other devices. I can't start to pull in that data in a way that is meaningful to me, or have access to it.
Right.
And I might have multiple hospitals, and so I want to have multiple viewpoints, but I just want to pull everything together. Can't do it. It's scalable. Mm-hmm. I like that. You were absolutely spectacular.
Oh, thank you.
Yeah, I really enjoyed that. How do people get a hold of you?
Contact RTI. You can find me in the webpage there, gerardo.rti.com, or reach out to RTI. Anybody there will be able to get you in touch with me.
It's RTI.com.
Yeah, right.
Not Real-Time Innovations. It is Real-Time Innovations, but it's RTI.com.
Exactly. Got it.
Make a note of that, listener. You're spectacular. I really thank you very much. I really appreciate the conversation.
Great. Thanks.
All right, listeners, we're going to have all the contact information out on Industrial Talk. And make a note, it's RTI.com, RTI.com. Go out to also OMG.org. Get engaged. You get to meet people just like the one we just had. Man, a great conversation. Thank you very much for joining. We're going to wrap it up on the other side. Thank you. Stay tuned.
You're listening to the Industrial Talk Podcast Network.
His name is Gerardo. Make a note of that. So all his contact information will be out there on Industrial Talk, so fear not. You need to reach out. RTI is the company. He is with also co-chair of Data Distribution Services. That is with the wonderful organization called Object Management Group, or OMG. That'll also be out on Industrial Talk. If you find yourself in need of an organization to get involved with, you need to connect with OMG too as well. Great conversation. There's a lot to unpack there. We just take it for granted. And I guess that's really good. If we see how the sausage is made, well then, that's not good. So kudos to the team at RTI. All right, we're building a platform. This platform is dedicated to you industrial professionals everywhere. You have a podcast, stick it on Industrial Talk. You have the need to sell something, stick it out on Industrial Talk. We're going to have another great conversation shortly, so stay tuned.